Thank you very much, Max. Hello, everyone. My name is Amila Akagic, and I'm Associate Professor at the Faculty of Electrical Engineering, University of Sarajevo. And this year, I had a pleasure of being one of the participants of the CLTP program. And here is a little bit about me and my experience in this program. So a little bit about my education. I actually received bachelor and master's degree from the University of Sarajevo in electrical engineering within the computer science and informatics department in 2006 and 2009. In 2007 and 2008, I had an opportunity to visit the University of California with Fulbright Visiting Student Award. And I also later on went to Japan, actually to Tokyo, to attend a PhD school, and I got my PhD degree in 2013 from Keio University. So I was very happy to be back in Japan in 2024 for this program. So currently, I'm actually working as an associate professor at the Faculty of Electrical Engineering, Computer Science, and this is our main building in the university, actually in Sarajevo, which is this is University of Sarajevo, and this is the oldest and biggest university in Bosnia and Herzegovina. I teach following courses such as artificial intelligence, methods and application of artificial intelligence, hardware software code design, digital signal processing, design and synthesis of digital systems, and some other courses as well. If I could talk about pillars of my research, these would be three pillars that I could just pick from a lot of different fields. So the first one is signal processing, the second one is computer architecture, and the third one is AI. In terms of signal processing, I work I work with image processing and image segmentation. In terms of computer architecture, I design in VHDL, and I also do application acceleration with OpenCL and OpenVINO. And in terms of AI, I do a lot of work with machine learning, deep learning, computer vision, and natural language processing. I was always curious about space technologies, and I took opportunity to actually study and understand a little bit more about satellites, but I would like to be able to work with AI and satellites. That means that I would like to maybe design some type of a satellite that has AI capabilities. I will talk about that a little bit later. So this is my country, and it's actually located in Bosnia, in Europe. And we like to say it's like a heart-shaped country in Southeast Europe, and you can see its location here. And its neighboring countries include Croatia, Serbia, Montenegro, Albania, and Kosovo. So in terms of my country, it's a very small country, but it has very nice cities and also very nice nature. So I picked some of locations in Bosnia and Herzegovina that I think are very interesting, such as the city of Mostar or city of Sarajevo, where I'm located right now. But also you can see a little bit about nature, like this waterfall Kravice, or mountains like Trstica mountain, or some type of rivers, that this is a Buna river and so forth. So if you're interested in Bosnia and Herzegovina, please search a little bit more about Bosnia on internet. So this year, I was one of the 10 participants, and I was very very honored to actually meet Max, Elmin, Eyas, Kim, Mattia, Mohammed, Sarbagia, also Kenan, and Malik. And I was introduced to this training by one of the graduates called Kerim Hajic. He graduated this program in 2011. And he was actually the one who gathered 4 people from Bosnia and Herzegovina to actually attend this training. So actually, 4 of us from Bosnia and Herzegovina attended this training, including Kenan Konjic. He's actually information security engineer in Bosnia and Herzegovina. Malik Kalem, he's a mechanical engineer and founder of Carbon Tech, and also Elmin Softic, who is cybersecurity engineer, and myself, of course. And this is also Matija. He's from Croatia, which is a very it's a neighboring country next to Bosnia and Herzegovina. So we had the opportunity to meet each other and talk about different topics. So our training actually started in August 19. Sarbagia already shows some images, but I also have some images, and I'm going to try to say a little bit more about this training. So the first day was only about briefing and introduction to CLTP, and we received these T-shirts and bags and books, and also Heptasat kit that we were supposed to work on. But also we received detailed instructions about locations, and everything was very well planned and organized. So we didn't have any problems in finding our way during this program. So in the first day, actually, we went to self-introduction, team building, and we also went to understand the Nihon University, and they gave us a tour about Nihon University. Afterwards, we also had some social events, like going out into this restaurant and also trying some different type of food. And we also needed to show our skills of cooking. I'm not sure how I did that in that part, but it was a very interesting experience. On the second day, we had to learn or apply everything from lab 2 to lab 4. So you can see these books, and we had to read all instructions and then try to assemble all the parts that were part of this satellite kit. And I think it was a very interesting approach, where you actually have to understand all the concept and then to apply all those concepts in a specific way. So since I'm coming from the computer science background, this was not too complicated, but it was very interesting to actually build something from scratch. And also to maybe try some applications such as this one, where we actually went and needed to go around the campus and try to build a map of where we were walking, and show the trace on the map. On the August 21st, we had to finish lab 4 and lab 5, where we actually tried to assemble and connect cameras and all different type of sensors, and also assemble the cube. So I'm not going to go into all the details, but on August 22nd, we had to finish lab 7. August 23rd was mission design. So we had to choose our team and also to work on specific mission. So not many of us understood what the mission is and how to build one, or actually what is possible and what's not possible. But we actually worked in a teams of 2 people. So, and we were able to somehow manage or understand what's the mission, what the mission is, and what is necessary to realize this mission and to implement it, and then present the mission. And for this mission, we needed some specific sensors, and we had to think about, okay, what are the possible sensors that we can buy, and we had a limited budget, and we had to go to Akihabara on August 24th to find these sensors, to procure the parts, and then afterwards complete our mission. On August 25th, we had a self-study day, and on August 26th and 27th, we were actually working on designing this mission and implementation, and we also had to present our mission. So I think this was very interesting way of building satellites from scratch, and then thinking about the mission, and then implementing that mission with the real components and real parts. So as already Sarbagia said, I was with him in one team, and actually our project was about detecting space debris and finding the size of the debris, and also location and velocity of debris. And when we find all this information, our goal was to send this data to the ground station for the further processing. So as you are probably aware, space debris is a huge problem, and we wanted to detect debris, but at some point we probably, as citizens of Earth, we will probably need to consider removing all these debris from space. So actually our goal was to design the satellite that is capable of locating, just taking a picture of the debris, and then determining the size of the debris and also location and velocity, so that we can actually map all the debris in space. So to be able to do this, we actually we needed to understand what is possible to do on satellite and what type of information from the sensor we need to send to the ground station, or to process some information in the satellite and then send the information to ground station. Unfortunately, in our Heptasat kit, we didn't have enough capability to process images on the kit that was available at that time. So we actually decided to only transfer images to the ground station and then perform image processing tasks on the ground station. So this is the limitation of current equipment, but I hope in future, when we have a little bit more advanced controllers or computers on board on satellites, it will be possible to analyze all this information on the satellites as well. So it is actually very challenging to kind of make a solution that is actually working. So Sarbagya and I were thinking about how can we take a picture of a debris. So we actually built like a box with a black paper on it, and we glued some rocks on this black paper, and we took a picture. We took a lot of pictures with the camera that was part of this satellite kit, and we created two data sets. This is the one data set that you can see, and on this data set you can see only one piece of debris, or this one stone that we actually created. And in the second debris, we wanted to show the capabilities of our algorithm to detect multiple debris or multiple stones. So this was the second data set that we actually created. And then we perform, of course, when we take this is the camera, as you can see here, and this is the ultrasonic sensor that is actually able to detect the distance of debris. So with the camera, we take a picture such as this one, and then we have to send this picture to the ground station, and the ground station actually analyze this picture with some image processing task or a tool. And this is what we get. It's a semantic segmentation. So basically what we did is we performed semantic segmentation on these type of images, and we actually tried to detect only the pieces that include debris. And this is the results of our analysis, where we were able to actually count the number of pixels of entire image and then count number of pixels of debris. Of course, this is only, we have been doing this only for 2 days, along with other sensors or implementing other sensors. So maybe in future with AI capabilities, we'll be able to do a little bit more. In the last 2 days, August 28 and 27, as Sarbagya already explained, we needed to transfer what we learned to 22 Japanese students, and they also had to assemble the cube in 2 days. So this is actually work of some of our students, which tried to capture an image of our aurora borealis and try to analyze some of the effects, or at least detect that there is such a phenomenon. So yeah, this is the end of my presentation. I really like to thank everyone that was involved in organizing this training. I had a very, very interesting time, and I met a very interesting people. I'm at the end of my presentation, so maybe maybe if someone has a question, I would be happy to answer.
Fantastic. Thank you so much for that wonderful presentation, Amila.